So this is atoms. Atoms were first suggested by the philosopher Democritus, and he lived in 400 BC, and he said that things in this world were made up of tiny particles called atoms. There was this other Greek philosopher that lived in 300 BC. His name was Aristotle. And Aristotle said, "Look, Democritus, I don't believe in your theory, I believe in the theory of hail. And I believe that this earth is made up of earth, fire, water, and air." So in 1903, J.J. Thomson comes along and says, "Hey, look, I have a cathode ray. I have this cathode ray tube. It's very similar to a computer monitor." And he finds these electrons. So he finds different particles in this atom. In 1911 came Ernest Rutherford. And Ernest Rutherford said, "Hey, I can find the nucleus of an atom with my gold foil experiment." So he ends up finding this nucleus, and he's another one of these big people that has to do with atoms. So the formula atomic theory has 4 things to it. The first one is that all atoms are made up of tiny indivisible particles. And the second one is if every different element has different atoms. The same element has the same atoms. The third one is that chemical compounds are made up of atoms coming together to form whole number ratios. The fourth one is that when a chemical reaction takes place, atoms are either combined, separated, or rearranged. An electron is also known as a lepton. And when you have an orbital, this is also like an electron cloud. And these electrons are going around in this 3-dimensional orbital all around the nucleus. And so here are the people that created these atomic models. So first you have the Thomson guy who said that, hey, these electrons look like rice, like plum pudding, and they look like little raisins. So you have Rutherford. Rutherford comes along and says, "Hey, look, I think this atom has a dense core but is made up of mostly empty space." And so you have Bohr. Bohr comes and he says, "Look, I have this electron, and I think that these electrons move around in the orbital in this nucleus called energy levels." And so afterwards, Ottoman theory comes along. He says, "Okay, I agree with Bohr, but I think that these particles move around randomly, and I think that they move around in all these different orbitals, and they're just random." So the only difference about that is Bohr thought of energy levels, and Ottoman thought just different random spaces. Okay, when you have hydrogen, hydrogen too has these little atoms, and they're going to be called deuterium. Hydrogen 3 has tritium. And so when you're explaining isotopes of hydrogen, you remember that isotopes have the same atomic number but different atomic masses. When you're looking for atomic mass units, you're going to look for the protons and the neutrons.